Hi, I'm Nick Ringsmooth, and this is my Physics 235 project. Today I'm going to be making some potato batteries and even using an apple as well to generate voltage on my multimeter. So we're going to start out by taking our red potato and we're going to cut it in half. And this way we're going to have two kind of potatoes that we can use as batteries, but we're going to just start out with one. Here I have a zinc nail and some copper wire. Now our copper wire is going to be our anode in this battery and our zinc is going to be our cathode. And I'm going to insert them in so that they have as much area with all the electrolytes in the potato as possible while they're not touching each other. So I have them both in. They're pretty much in all the way. And now I'm going to take the ends of my multimeter testers and we're going to test this and see if we can get any voltage out of it. So right now looks like I'm generating some voltage. It's fluctuating a bit. Let's see if I can get it to a constant state. And it looks like we're resting about 0.876 volts, so around 0.9 volts, which is pretty decent. But now what we're going to do is we're going to take these other fruits and we're going to hook them up in series, which is going to give us more voltage, but it's going to give us less current because not only are these potatoes acting as batteries, they're also acting as resistors. So we're going to cut the next one. Got that. Then we're also going to use an apple because of fun. So first, let's actually just test the apple on its own and see what kind of measurements and readings we can get from that. We have our anode and cathode. We can test these. So hook these up, get a multimeter reading, and it looks like our apple is getting us 1.01 volts. So even more than the potatoes got us. So it's pretty interesting. Must mean the apple has even more electrolytes. So now we're going to take our remaining zinc nails and put them in our potatoes. Let's look at the surface area. Okay, now we're going to hook these up so that each anode is in contact with the cathode of the next one. I think that's pretty good. That should be in contact in multiple areas. Now we can take next copper wire, wrap that around. So for this project we had a couple different options for what we could actually do, and one of the options was like write a paper, one of them was make like a 10-minute long YouTube video, or one was actually physically build what we were discussing. So that's what I'm doing here, just showing off my creation as proof. Okay, so we've got those two. Now we're going to take, let's see, this one. So if we were trying to get current or amperage out of this circuit, quote unquote, we would probably want to hook these up in parallel versus in series because, like I said, since these potatoes are also acting as resistors, it would basically kill a lot, if not all of the current. Well, I suppose it can't kill all of it, but it would kill a lot of it, and it'll still leave a lot of volts, but not very many amps at all. So, but since we're just trying to get volts or a voltage reading off of our multimeter, that is all we need to do. Series will work just fine. Okay, so now if you can see, we have our cathode here, anode, cathode hooked up in series with all of our things, and then we have one one cathode and one anode left in the end. So now we're going to take these testers, put them on there, and we are getting 1 point, let's see, can this even read it? Let's put this up one more, see if we can get that. There we go. Up. Okay, before it bop, there we go. We're getting like 3.2 volts out of this series quote-unquote circuit. So yeah, pretty cool, making voltage from electrolytes in foods. So this is Nick Ringsmooth. This is my Physics 235 project. Yeah, that's all for this video, so signing off.